Today we're going to go through each problem on the Unit 5 review, starting with the first one, y equals the square root of 2x minus 8. So we're just going to type that right into Desmos because it's asking us to graph. All right, and clearly we can see that our graph is this little red curve right here. We need to get it onto our review. So I'm going to go ahead and press the gear wheel in the table to find out some nice points. As you can see, I don't have any until I get to 4, and then I have the point 4, 0. One, two, three, 4. And then I have the point 6, 2, which is another pretty nice point. Seven, 8, 9, and that's the end of my graph right there. So 9, 3.16, I'll approximate it. And that'll give me enough points to get the general shape of this curve. And now we're going to look at the domain and the range. The domain, as I move across the x-axis, here's my cursor, as I move across the x-axis, where is their graph, above or below me? Well, there's graph here to infinity. So my domain is going to be from 4 to infinity. And in fact, I would also go so far as to include 4 because x can equal 4. Now we'll take a look at the range. As I move up from the bottom to the top on my y-axis, where is their graph? Well, there's graphs starting at 0 and going all the way up. So my range, starting and including 0 to infinity. Let's take a look at the next one. We have a different type of function. This one is a cubic function. So going back over to Desmos here, we want to type this new function in. I'm going to exit out of my old one. And I'm typing y equals, next I need cube root, so I'm going over to my functions button, miscellaneous with an n, that'll allow me to put a 3 there, and then I'm typing x minus 3, and then outside plus 10, a picture of it so that I can determine the domain and the range. And as you can see here, the graph goes all the way to the left and it goes all the way to the right. And even though it doesn't look like it's going down very much, it goes down forever and it also increases and goes up forever. So when I'm talking about my domain and range for this next one, I can simply say all real numbers for both the domain and the range. And behavior, as x approaches infinity, or goes to the right, the graph goes, as we go to the right here, it goes up, positive infinity. And then we rewrite it as x approaches negative infinity, f of x approaches, in this case, negative infinity. It goes down as we go to the left. And our point of inflection here is going to be the point 310. That's the point where it kind of changes its concavity right here. And that is our point 310. It's hard to get it exactly on there with Desmos. There it is, 310, the point of inflection. Another one to graph. Now we have the cube root of x minus 2 plus 3. And we look at the table because we do want to get these points on our graph. And the point 1, 2, 2, 3, 3, 4, those are all pretty nice points. So let's start with those three. 1, 2, 2, 3, 3, 4. So it kind of goes up this direction, and then it goes down this direction. The diameter of a tree, d in inches, is related to its basal area in square feet. By the formula, d equals the square root of 576 times the basal area over pi. If the diameter of a tree is 47.9 inches, what is the basal area of the tree? And we will use a calculator to get our answer to the nearest tenth. So, what do they tell us? They tell us that the diameter of the tree is 47.9. That's what's going to go in for our d value. 47.9. And on the right, 576 times the basal area divided by pi. So now I need to solve this. First, I'm going to square both sides to kill the square root and eliminate that. On my calculator over here, I'll do 47.9 squared, and I get 2294.41. And on the right, I now have 576 times the basal area divided by pi. So I multiply both sides by pi. I'll do the same thing over here. Let's multiply. I'll just type in 3.14159. That should be pretty decent. Digits of pi. And then finally, to get the basal area alone, I need to take that answer and divide by 576. And I get 12.5 square feet. All right, looking at number 8, we need to solve this. To eliminate a cube root, we must cube both sides of the equation, which gives us 3m plus 1 equal to 64. That's 4 cubed. Take away 1 on both sides and divide by 3. M equals 21. Plugging that back into our equation, we would get the correct answer. We'll use Desmos to check that. Let's type the cube root of 3. Didn't want to jump to the next line just yet. Times 21 plus 1. And that does equal 4. So we know that we're correct. Okay, moving to the next page already. Number 9. For number 9, we need to solve for y. It just says solve, which means solve for the only variable we see here. We need to get rid of everything on this side of the inequality except for the letter y. We need to get rid of the 4, the negative, the square root, the 5, the negative 10. In a specific order, of course. So first, let's get rid of this 4 by subtracting 4. That gives me negative square root of 5y minus 10 less than or equal to negative 5. Next, we can either multiply or divide by a negative 1 to eliminate this negative and this negative, which causes my sign to flip. So now I have the square root of 5y minus 10 greater than or equal to 5. To eliminate the square root, I need to square both sides. So 5y minus 10 is greater than or equal to 25. Next, I would add 10 to both sides. 5y is greater than 35. and dividing by 5, y is greater than or equal to 7. For number 10, the velocity v in feet per second of a roller coaster at the bottom of a hill is related to the vertical drop h in feet and the velocity v sub 0 in feet per second of the coaster at the top of the hill by this formula. If the coaster has a velocity of 20 feet per second at the top of a 150-foot hill, so we have this information, 20 feet per second at the top. That is the V naught, or the V sub 0. Because up here it says V sub 0, or V naught is another way of saying that, is at the top of the hill. So I can put 20 into my formula for V naught. I'm trying to figure out the velocity at the bottom of the hill, so I'm going to leave that V. And I also know the height of the hill. It's 150 feet. So I put that in. And now I need to solve. So again, the first thing I do to both sides is square it to eliminate the radical. So I have 400 equals V squared minus 64 times 150. So 64 times 150 gives me 9,600. So let's substitute that. Let's call this 9,600 instead. So adding 9,600 to both sides, I now have 10,000 equal to V squared. And then finally taking the square root, I get that V equals plus or minus 100. Well, we're talking about velocity. You can't have a negative velocity, so we end up with 100 feet per second. We don't consider the negative solution that we picked up extraneously. Next, we have a radius of a sphere. They tell us that the radius has this formula, 3 times the volume divided by 4 pi to the 1/3 power. They also tell us that the radius is 2.5 centimeters. So the first thing we're going to want to do is cube both sides to eliminate the 1/3 power. Now I have 2.5 to the 3rd equals 3v over 4 pi. And I'll multiply both sides by 4 pi. And finally divide by 3. When I type this on my calculator, my volume to the nearest tenth, so we're going to be rounding, ends up being 65.4 centimeters cubed. Moving into step 18, now we're talking about rational expressions, not radical expressions. We need to know what values of x make this expression undefined. And I can only tell the values when I look at it in factored form. So I'm going to start by factoring this. That's a negative 18, 2 times negative 9. Factors of negative 18 would be 1 and negative 18, 2 and negative 9, 3 and negative 6. I'm looking for a winning combination that's going to combine to negative 3, which is right here. So I take my a value, which is 2x, and I put the winning combination underneath and reduce if I can. If I cannot reduce, I just write it as is. But over here I can reduce, and I'm left with x minus 3, 1x over negative 3. I set each piece equal to 0 and solve. This gives me x equals 3, and this gives me x equals negative 3/2. Those are my two values for which this is going to be undefined. my work out of the way here a little bit so we can continue on with number 13. We need to simplify each expression or perform the operations. That's another way to think about it. Well, when we see divide with fractions, we want to keep the first fraction, change to multiply, and rewrite the second fraction by flipping it. The first fraction, we could factor the denominator. And before we multiply, we could also eliminate some of these factors. X plus 8 and x plus 8 will eliminate. Right here, I have 2 x's on the bottom and 3 on the top, which leaves behind 1 x on the top. So my final answer, on the top I have just x, and on the bottom I have x minus 8. For number 14, we can also factor. I'm going to factor out a greatest common factor of this numerator, leaving behind b squared plus b minus 2. This trinomial would factor as follows: b minus 1 times b minus 5. Negative 1 times negative 5 multiplies to positive 5 and combines to negative 6. Here we have a difference of squares. b minus 5 times b plus 5. And in this denominator, we have a greatest common factor again, leaving behind a b plus 2 after we factor out a 6. The only other thing we can do is look at this trinomial here. This also factors. b squared plus b minus 2 factors to b plus 2 times b minus 1. So I'm going to go ahead and replace that. b plus 2 times b minus 1. And next I'm going to eliminate factors from the top to the bottom that are identical. So here we have a factor of b minus 5, factor of b plus 2, factor of b minus 1. I can also cancel the 3 with the 6, leaving behind a 2. So my final answer, looking at the top, there's just b plus 5. And in the denominator, I have a 2. Everything else is canceled out. Number 15 looks kind of complicated. It's not too bad though. We have a fraction divided by another fraction. So we're going to just rewrite this, 3m squared minus 75 over 6m squared plus 30m. Change the sign to multiplication and flip the second fraction. 9m squared plus 45 is now my numerator, and 4m minus 20 is now my denominator. And now we want to factor as much as possible. 3 leaves behind m squared minus 25, but I know that's a difference of squares. So I'm going to change it right away to m minus 5 times m plus 5. Down here I can factor out a 6 and an m, leaving behind an m plus 5. Up top here I can factor out a 3 and an m, leaving behind 3m plus 15. Oh, it looks like I could have factored out a 9 actually. I would have looked a little more closely. 9m will factor out, leaving behind an m plus 5. And finally, a 4 factors out, leaving behind an m minus 5. Grabbing a new color, let's eliminate. M plus 5s cancel. M minus 5s cancel. Remember, you can only cancel them in pairs, so while there still is an m plus 5, there's nothing to cancel with that, so it has to remain behind. These single m's cancel. 6 and 9 will cancel, leaving behind a 3 and a 2. And I think that's about it. So for our final answer, we multiply across the top 3 times m plus 5, which is 9 times m plus 5. In the bottom, I'm left with a 2 and a 4, which makes 8 when I multiply. Number 16. We have to subtract, which means we first have to have common denominators. This denominator is really x minus 2 times x plus 2. This denominator already has the one factor, it just needs the other factor. So I'll give it to the first denominator, but if I do that, I have to also do that to the numerator. Now I have 2 times x plus 2 over x squared minus 4, because that's what I get when I multiply them. Take away 8 over x squared minus 4. So my answer, I know the denominator is x squared minus 4. In the numerator, I have 2x plus 4, take away 8, which is negative 4. Now this is a beautiful answer, but things will factor. 2, leaving behind an x minus 2 with my greatest common factor approach. And right here, remember, that was x minus 2 times x plus 2. So canceling, I have a like factor on the top and the bottom. So my final answer is simply 2 over x plus 2. People say sometimes, do I have to simplify it all the way? If you want the best answer, yes you do. All right, on this next one, we look at the denominators and they are not like, but fortunately they are completely unlike, complete opposites. 3m minus 1 and 1 minus 3m are completely opposite. So I can simply factor out a negative here, and I can switch the order of these two terms, which leaves me with 3m minus 1. Now you can see that I have these common pieces. However, I also have this negative right here. So that's a problem because this first fraction doesn't have a negative. But something I can do with this negative, I can take this negative and use it to cancel out the negative that's right here, where two negatives make a positive. So now I have 5 plus 2, which gives me 7 over 3m minus 1. All right, let's find the least common multiple of each set of polynomials. That's the smallest number that I can make that would represent all of these. Now I can't just use 18 because 4 doesn't divide into 18. But the next number, 18 times 2 would be 36. I can divide 36 by 4, 9, and 18. So I'm happy with that. Then I look at my letter m, my variable m. I need to have the least common, which would be m to the 4th. And then finally, p to the 4th. If I were making a common denominator, they would have to all be 36 m to the 4th, p to the 4th. I would have to multiply this one by 9m, p to the 3rd. I would have to multiply this by 4, m to the 3rd, p, and I would have to multiply this last fraction by 2p squared, just so that we could have this common denominator. On the next one, if we factor it, n minus 4 times n plus 2, and the second polynomial factors to n plus 6 times n minus 4, you can see that they both have a factor of n minus 4, but the one on the left has a factor of n plus 2, and the one on the right has a factor of n plus 6, and the least common multiple must represent all of them. So it would be n minus 4, n plus 2, n plus 6. Vertical asymptotes and discontinuity. When we're looking for vertical asymptotes, we just look at the denominator. And we think, what could x minus 3 not equal? We don't want the denominator to be 0. And that's going to happen when x equals 3. Where is this next function undefined? This will be undefined at x equals negative 2. Now we need to decide if these points where they are not defined are vertical asymptotes or holes, which are also known as points of discontinuity. If this factor will not cancel with the numerator, this is a vertical asymptote. If you can factor your numerator here, this would factor to x minus 4 times x plus 2. If these factors can cancel, that makes this undefined point or undefined value a hole or point of discontinuity. And then the last problem on this page, we want to graph this rational function. Again, using Desmos, we're just going to type it in. On the top, we have x plus 3. And on the bottom, we have x minus 2. And then we look at our table to find some nice points and plot as many of these as we can. So negative 2, negative quarter, negative 1, negative 2/3, and so on. And we can even extend our graph a little bit more to the right to try to get a few other nice points. So negative 2, negative 1/4, negative 1, negative 2/3, 0, negative 1.5, 1, negative 4. 2 is undefined because that's a vertical asymptote, if you recall. Number 3, 6, which would be up here. 4, 3.5. 5, 2 2/3. 6, 2 1/4. And then we connect these as nicely as we can, approaching the asymptotes. Notice there would be an asymptote at y equals 1. Because the degree of the numerator equals the degree of the denominator, which means the asymptote is the ratio of leading coefficients. So I also have an asymptote right here. And compared to its parent function, this has gone 2 to the right and up 1, even though it doesn't ask us that. All right, moving on to the last couple pages. Solve each equation or inequality. To solve this equation, I'm going to multiply by the denominator that's causing fractions. And I multiply each fraction. So I end up with x times x minus 2. In the second fraction, the x minus 2 cancels from top to bottom, and I'm left with just 2x. And in the third fraction, same thing. They cancel, and I'm left with 3x minus 2. Distributing, I get x squared minus 2x plus 2x equal to 3x minus 2. These eliminate, and I move these terms to the left because I need a quadratic to equal 0 so that I can solve it. And I factor. X minus 2 times x minus 1 multiplies to 2 and combines to negative 3. This means x is 2 or 1. But remember, x cannot equal 2, looking back at the original problem. So x equals 1 for my final answer. When we're dealing with inequalities, we make a little note that m cannot equal, in this case, 0. And then we solve it just as we did the last problem. This gives me 9m plus 2 greater than 47. And when I solve that all the rest of the way, I get m greater than 5. But recall, we need to make our number line and list the domain restrictions and the value that we just came up with and test the pieces. So we're testing with 9 plus 2 over m equals 47 over m, our original problem. So I'm going to pick a point over here, like negative 1. If I replace m with negative 1, remember the original problem, this was greater than. Is 9 minus 2, that would be 7, is that greater than negative 47? Yes, it is. So we keep this portion. Then I'm going to test with something in between 0 and 5, like 1. Is 11 greater than 47? No, it is not. And then finally, I test with a point somewhere above 5, like 10 or 6. It really doesn't matter what you choose, as long as it's bigger than 5. And here, 9 1/3 is going to be bigger than 47/6. So we will keep that part. And we write our final answer in interval notation from negative infinity to 0, and then from 5 to infinity. We're going to skip number 25. And the bonus, we will come back to that if we have time at the end of the video, but it's just bonus. Let's sketch this graph. Here, again, we go into Desmos. And we type this expression, 1/2 times 3 to the x. And we look at a table of values because it does ask us to graph it. A lot of graphing. 0, 1/2, 1, 1.5, 2, 4.5. And then you can see it gets smaller and smaller as we go to the left. There's our graph. Okay, the domain and the range. Well, I have graph everywhere on the x-axis, but on the y-axis, it is simply above 0, and it goes all the way up. Here we look just at this base, 2/3. Because 2/3 is less than 1, this represents decay. Next, we need to solve some exponential functions by finding a common base. 9 can be rewritten as 3 squared to the 4x plus 4. 243 can be rewritten as 3 to the 5th to the 2x plus 2. Distributing with my exponents, And eliminating my common base, I now have 8x plus 8 equal to 10x plus 10. And solving, 2x is negative 2, so x is negative 1. This next one, I'll replace 1/6 with 6 to the negative 1, and I'm not going to do anything different on the right side. Now I have common bases that can eliminate, which gives me negative 1 equals n plus 4, subtracting 4 from both sides, n equals negative 5. I can express both of these as powers of 2. 2 to the 5th times x, and 2 to the 4th times x plus 2 would make that an 8. 4 times 2. I have to do distributing. I have common bases now, so 5x is less than 4x plus 8. Subtracting x from both sides, I get x is less than 8. Rewriting an exponential form, we start with this small base number, we go to the other side and back around, making that e for exponential form. So it would be 81 to the negative 1/2 equals 1/9. Evaluate. We can simply type this on our calculator, and if we do, we will get 7. Same thing for the next one. When we're just evaluating this, again, if you're using your TI calculator, it's Math Alpha Math. Again, if we're using Desmos, that's fine too. We would simply type the log and then shift minus to make it a base of 5, 128. That gives me 3.5 for my answer. For this next one, I want to change to exponential form. 36 to the 3/2 equals n. Typing this on my calculator, I get that n equals 216. We're in the home stretch. Just a few more to go. Continuing to solve. When I have two logs with the same base, I can rewrite them as one log by first taking coefficients and making them exponents, and then changing the sum between the logs to a multiplication of these components. 81 to the 1/4 is simply 4, because 3. I think I misspoke. 3. 3 is the 4th root of 81. And the 25 to the 1/2 is just 5. So now I want to multiply the 5 and the 3 so that I have just one log on the right. Log base 4 of 3 times 5 is 15. And over here, I have the log base 4 of n. Once these values right here are the same, we can just ignore them, and we get n equals 15 for our final answer. For the next one, again, we can combine these logs. There are no coefficients, so we'll write 1 log base 2. We'll take the first component and make it the numerator and divide by the second component because we have subtraction, which means we want to divide them. And this equals 3. Next, I need to change to exponential form. by saying 2 to the third equals 2x plus 6 over x. 2 to the third is just 8, and multiplying both sides of this equation by x eliminates the rational fraction. So now I have 8x equals 2x plus 6, subtracting 2x from both sides, and dividing by 6, I get x equals 1. Condensing our logs on 37, we have the log base 3 of x plus 3 times x minus 2. We're multiplying them because there was an addition sign. And I'm not doing anything to the right side. I can eliminate the word log base 3 and set just these components equal to one another, which when I multiply means I have x squared plus x minus 6 equal to 14. Subtracting 14 from both sides, we get subtract 20, and then we factor this because it is a quadratic. X plus 5, x minus 4, solving x equals negative 5, or x equals 4. Now remember, you have to go back and check, and if we were to put a negative 5, we would end up with negative 5 plus 3, which is negative 2. We cannot have a negative number here in our logarithm. So we throw this out, we would check 4, and it would work, and that is our answer. For the next one, we're trying to solve for n. It's trapped in the numerator. So I'm going to simply rewrite it in logarithmic form. Log base 6 of 50 equals n minus 2. I could have also taken and put a log on each side. That method works as well. And then I would have to add 2 to both sides. Typing this on the calculator, n ends up being approximately 4.1833. For the next one, I really need to put a log on both sides. Take the logarithm of both sides because I have not one, but 2 y's in separate locations. So I'm going to say the log of 2 to the y and the log of 5 to the y minus 2. These exponents can now jump over the logs. Y log 2 equals y minus 2 log 5. I'm going to subtract y. Well, first I'm going to distribute actually, because I don't want the parentheses. Then I'm going to subtract y log 5 from both sides. And over here I'm left with negative 2 log 5. I'll factor out a y. And I'll divide both sides by log 2 minus log 5, which eliminates it over here. And this is approximately, when you type that in your calculator, 3.5129. All right. We're going to skip number 41 also and go right to 42. Compounding continuously, they tell us what formula to use. We know that we're putting in $3,000. We know that it's e to the 0.02 times 5 for 5 years. That's my rate. Simply typing this on the calculator, my answer is 3315.51. Solving this natural log equation, again, I can rewrite it in exponential form the base, even though you can't see it, is e to the third equals x minus 5. Then I need to add 5 to both sides. Plug this into my calculator. X is approximately 25.0855. Going in reverse, now I want to write this in logarithmic form. The natural log of 9 is less than or equal to negative 4x. One thing we need to be mindful of here, though, when we're doing this is the fact that it's an inequality. So for this problem, it's probably safer to take the natural log of both sides. The natural log and the e cancel, and now I have negative 4x is less than or equal to the natural log of 9. I'll divide by negative 4, which flips the symbol, and I end up with x is greater than or equal to negative 0.5493 for my final answer. Here we're talking about a radioactive element. We know that the formula is y equals e to the kt. And we know that we're talking about the half-life. So if we start with a 16-gram sample, it's going to end up equaling 8. So I'll put 16 here and an 8 here. Dividing both sides by 16, I get 1/2 equals e to the kt. And I know that it's going to get to its half-life in 12 hours because it tells me that. So I'm going to put a 12 in for the time. And next, I just need to solve this. I'm going to take the natural log of both sides. Natural log of e cancels. I divide by 12. And I know that k is approximately negative 0.0578. So my new equation would be y equals 16, that's how much I'm starting with, e to the negative 0.0578t. Using a savings account, we're going to put $150 to earn 6.5% interest. We want to know when is it going to be $450. That's how much I'm ending with, so I put that on the left side. Put 150 on the right side, and I continue using the formula laid before me here to the t, dividing both sides by 150. And then taking the log of both sides. The t can come down front now. And I'll divide both sides by the log of 1.065. And I find that t is approximately 17.4 years. And then finally, we have just another bonus problem. I hope you find this video helpful, and if you have questions, please feel free to email me.